Hey everybody, good morning. Happy Sunday. How are you? It's so good to be spending time with you today. Hope that everyone is doing well. Wow, what a day. What a day. I gotta tell you guys, today is a day with mixed emotions because I'm so happy that we get to spend the time together and we get to, finish out the book. But at the same time, it's been a great journey. It's been a lot of fun to be able to share the introduction to statistical learning book with you. And we're at the end. We're at the end of that journey. It's just so incredible to think that. So, just really grateful and really happy for all of you that watch my content and have enjoyed the class. I've certainly enjoyed it. It's taught me a lot as far as my own teaching capabilities and my own revisit of the book, because this is my first time revisiting the book in a long time. And it's also shown me, how much my own skills have evolved and advanced and all that. So it's been I just can't tell you how grateful I am for the opportunity overall to just be able to teach this to you guys. So yeah, really kind of a bittersweet day today. So looking forward to spending time together. Obviously, I think we have an interesting chapter, but I'm gonna be sad when it's done. If I'm being honest, I'm gonna be sad when it's done, guys. So credit to all of you for hanging in there, for participating the whole time, for just being a part of all this. I know there's a few of you who attended every course. Some of you who managed to stay the entire time for every single time, which is great. So congratulations to all of you too. So also we have quite a few new people joining. I'm getting quite a few on Instagram. I'm also getting about 1,000 new followers a day on YouTube. So welcome to all the new viewers. If this is your first time watching, I stream every day at 1500 GMT. I usually stream, kind of like ask me anything questions where you guys can come in and I take on all questions, all comers. But on Sundays, I like to do an instructional series. So we are finishing out the Introduction to Statistical Learning book. Today is session 8. We're going to be doing chapter 10. So you're welcome to stay. Maybe not all the sections will make sense to you, but you can stay. You can add to your notes. You can add to your knowledge. And then when you have the time, go back to my channel. I have every single chapter laid out in a playlist. And that chapter will help you understand everything that we've covered so far. So that's a way for you to get caught up and kind of, just understand what's going on with this book. And again, the reason why I decided to teach this book is because this book is where data science, professional data science really begins. Forget all the tutorials, forget all the experts online, forget all the Coursera courses. If you want to do professional data science, it begins with the Introduction to Statistical Learning book. Okay? So usually I would do a global roll call, but we're not going to do that today because I do want to get to the materials as soon as possible. Because another thing, the new people should know is that these sessions have tended to run long. I think our longest one was 3 hours. I don't think we've gone anything less than 2 hours. So, somewhere between 2 to 3 hours. So maybe, you have to leave during the first hour. That's okay. Come back. We're likely to still be here. You never know, right? So I'm going to quickly go through some of the greetings, and I see a couple of questions in the chat. But then we're going to get right to it. We're going to get right to chapter 10. So starting off, Rohan, our good friend Rohan, and once again, he's first in the chat. Thank you, Rohan. Good to see you. Such a great supporter. Good morning, Dennis and all. Rohan from Vizag, India. Thank you, Rohan. Always appreciate your introduction and greeting everybody in the chat. Yassine, another great supporter. Yassine, I think you're one of the people who's been here for every single class, so thank you so much. Hello, sir. Yassine from Tangier, Morocco. Welcome, Yassine. Glad to have you here. Yassine, I think you're going to be learning more from this than you are from your university classes. We'll see. We'll see. Rex, our very talented moderator on Twitch. Says, it's data science o'clock. Good day, everyone from New York City. Thank you, Rex. A great introduction. Good to see you too. Crazy Susie. Hello, everyone. Susie from Bangalore, India. Thank you, Susie. Good to see you. Casual Economist, our good friend Casual Economist. You've been a great supporter since you first found us. I remember you told me when it was your first day, and you basically went back every single day. That's a compliment. I appreciate that. Another day, another 1,000. Yeah. Casual Economist is referring to my growth on YouTube. I've been averaging about 1,000 new subscribers a day on YouTube. So yeah, it's been crazy, guys. It's been crazy, and keeping up with the comments and the messages, it's been crazy. Like I wish I could afford to hire another person, because it's a lot of comments and stuff that I have to keep up with, and I do my best to give personal replies. And I'm also getting a ton of stuff from vendors who want to sell me all kinds of different things. But yeah, it's tough, guys. It's tough. But thank you, Casual Economist, for being here. Phil, I think this is your first time. If it is, welcome. My quick question is, as I'm joining for the first time, are you going to start from scratch again? Oh no, Phil, geez, no. There's 10 chapters to this book. This is a big book. I can't start over from the very beginning every single class. We do a chapter per class, but what you can do is you can go to my YouTube. I have a playlist that has every single chapter or every single session individually, because the first session we did cover the first 3 chapters, and then we did 1 chapter afterward. But no, I do not start each class from scratch. That wouldn't be fair to the people that have been coming, and it would make the sessions super long. But you are welcome to watch the replays. I think they are laid out in a pretty easy manner. Also, what I do, and you might see this afterwards, is I will play all of the sessions, all sessions together. I will play them together as a loop, on a continuous loop overnight. And that way you're able to see it. You can come back to it, maybe watch a few minutes, come back, kind of throughout your day or whatever. But it will always be there, coming back, whenever you have some time to invest in it. But no, today I'm not going to be starting all over. It's going to be chapter 10. We're going to be talking about unsupervised learning today, okay? Lakshmi, our good friend Lakshmi, says, hi, Dennis and all. Hi, Lakshmi. Good to see you. Hope that you're doing well. I think you're from India, Lakshmi, but welcome. Glad to see you. I know you've been a consistent attendee on Sundays. So hope you're doing well out there, Lakshmi. Fatima, so hello, or hey, Fatima from Morocco. I love these classes. Thank you, Fatima. Yeah, I think I've seen you on Sundays before. Tell us what part of Morocco you're from, Fatima. Lots of people from Morocco, and Morocco's a big country, so let us know. Rohit, our good friend from Bangalore, India. Nice to see you, Rohit. Casual Economist, if you need help with stuff as you keep growing, I'll volunteer. I appreciate that. Thank you. I just don't know if there's mechanisms out there to allow other people reply to my comments and things like that. But I like to keep it a little personal, so we'll see. I'll keep you in mind. It's a good idea. We'll see. There's a lot of things coming up. I have a lot more content that I want to get out. I'm expecting a ton of growth between now and the end of the year. So yeah, we'll see. We'll see how things go. Abby PC. Abby, I think this is your first time. If it is, welcome. Hello, everyone. Abhijit from India. Welcome, Abhijit. Thanks for joining. Anis says, hello, everyone. Hello, Dennis. Anis from Algeria. I'm an HR professional with the goal to become a data professional. As usual, I'm grateful that Dennis was outstanding content. Oh, thank you so much, Anis. Thank you. I appreciate that. Yeah, I think you had looked at my mid-career transition video, if I remember right. Yeah, so welcome. Again, if you guys are really serious about making a move into data science, it begins right here. This book is where professional data science begins. I guarantee you every, bona fide data scientist you meet knows this book. So today we're going to finish it out. Chapter 10. That's it, guys. We're done. We're done after this. So like I said, go to my YouTube. There's a playlist. I'll also post the playlist on my Discord. You can have a direct link and just go through each one of the chapters. It's going to take you a while. I think after today, it'll be like 18 hours of content, 20 hours of content, something like that. So it'll take you a while. It's a commitment. It's a big commitment. But, you know, again, if you want to know how professional data science is done, right? You know, not some dummy influencer who's never worked a day in their lives in the industry, but I'm talking about, you know, real data science. You know, this book is really where you should focus, okay? Mason, good to see you again, Mason. I don't think I've seen you in a bit. Mason says, hey, Dennis, watching from Pittsburgh. Nice. Welcome, Mason. Fatima says, exactly in Meekness. Very cool. I've been to Meekness. Nice city. Lots of families in Meekness. So yeah, cool. Abby says, yes, this is my first class Dennis. Well, welcome, Abby. Welcome, Abby. You're towards the tail end of the book. You know, we're on chapter 10. It's the last book. It's last chapter. But again, I invite everyone to go ahead and go back to the playlist, or as I said, I stream it on a loop. You know, so every once in a while, you know, if you subscribe to my account, you'll see it come up in your recommendations, or if you go to my account, it'll say live streaming. And it might be in the middle of the night for you or whatever. You know, watch some minutes before you go to bed, or, you know, when you're walking around during the day or whatever. But I play it on the loop so that you guys can, you know, leave it, come back, leave it, come back. I do that because that's the way I learn best. You know, sometimes I gotta read something and then I gotta be like, yeah, okay, cool, let me step away from that and think about it a little bit, come back to it. So that's why I play it on the loop, to kind of help people learn in that way. Okay? All right, guys, so I think that's all the introductions I'm seeing. So I say, let's get started. You know, let's go ahead and do this, right? And like I said, guys, it's definitely bittersweet for me because I've enjoyed this time, and just, I just can't believe we did it, guys. We did it. 10 chapters. That's amazing. All right, so let me switch to my classroom view. So if you're on Instagram, this is where I might lose you because Instagram doesn't do so well with my widescreen view. So I encourage you to, if you would like, to switch over to YouTube. I have the link pinned in the Instagram chat where you can find us directly on YouTube. The format is just a little better. You're welcome to stay on Instagram. It's just a little bit easier to see on YouTube. And also for the new people, you know, my previous attendees already know this, but I also use the Socratic method, so I'm going to be asking you a lot of questions, so please feel free to participate. There's no wrong answers, no one's going to make fun of you. Just, you know, it's part of the learning process, right? All right, chapter 10, unsupervised learning. What is that? What is unsupervised learning? So start filling up my chat. Let me know. What is it, guys? What exactly is unsupervised learning? Actually, you don't have to give me the right answer. Just give me your perception of what unsupervised learning is. That's totally okay too. What do you guys think? Hey, AE Robotics, welcome. So AE Robotics, the current question in front of the chat is, what is unsupervised learning? Just give me your thoughts on it. Like, what is it? So Yassine says unsupervised learning is a type of statistical learning when the goal is to understand and extract some common patterns in data where no labels or targets are available. Okay, cool. Thank you for that, Yassine. Kaiser says, let's assume a teacher teaches you in class that's supervised, and accept if you study at home without any any supervision. Okay, all right. All right, I love the examples, the analogy there. Rohan says the model does not have any data or help from humans. Okay. Anybody else? Last call for unsupervised learning. AE Robotics says learning from unlabeled data. All right. Fatima says type of machine learning that involves analyzing and clustering unlabeled data. Okay. Rohit says learning from data where it is not properly formatted or labeled and the algorithm teaches itself by giving itself points. All right. Thank you, Rohit. Anis says unsupervised training is a type of machine learning where models are trained without explicit labels. I believe it's the opposite of supervised learning. Okay, I like your tie back to supervised learning. Yeah. This method uses algorithms to discover hidden patterns or groupings within the data. All right. All right. Good. Good. I love all the answers. I think all of you are on the right track. The one thing I do kind of want to, kind of set the expectations on, right? Is the way I think about it is it's not necessarily a problem of data. It's a problem of the world, right? Because a lot of you are mentioning, well, the data's unlabeled, right? But it's not unlabeled like for a good reason or a bad reason. It's that we don't live in a world where everything is labeled, right? We don't always know the outcomes, right? Crazy Susie, I like your definition: discovering insights without following a particular regimen. Yeah, or data that doesn't follow a particular regimen, right? Because that's the way the world is, right? So that's the way I kind of like to think about it, to kind of, from a student perspective, right? When I thought about that, that's when it kind of helped me understand it, right? We just don't live in a labeled world. And in fact, when I was doing my studies, I remember the example that was given to us was medical studies, right? Like if you think about yourself as a medical researcher, that's like unsupervised, right? Patients don't always come to you with a label on their forehead that says, I have a new type of blood cancer. You have to discover that they have a new type of blood cancer, right? Like, well, how would you do that? Well, you would look at their age and their lifestyle and their weight and, medical history and operate, right? Like you have to kind of piece it together, right? Because again, the world is not labeled. So when you think about unsupervised learning, I'd encourage you to think of it that way. That we just live in a world that doesn't always have a label. There's going to be problems where you don't have that dependent variable that we've been relying on, right? So let me ask you guys this, and if you read the slide that's on the screen, you can probably kind of see where I'm going with this, right? Let me quickly look at this. Shiha? Is it Shiha? Example of it is clustering algorithms, right? Yeah, we'll get to that. Yes, you're on the right track there. But let me ask you guys this, okay? And again, if you're reading the slide, maybe you already know where I'm going with this. So if we accept that we don't live in a labeled world, and we're coming up with our own ways to interpret the data, can you have a confusion matrix in unsupervised learning? Give me a yes or no in the chat. Can you have a confusion matrix in unsupervised learning? And remember, just in case you guys don't remember, with a confusion matrix, we're talking about our accuracy, we're talking about our true rates, our false rates, our true positives, our true negatives, right? Does that exist for unsupervised learning? So let me know. Just give me a simple yes or no in the chat. No one's gonna call on you, and just let me know what you think. So I'm still seeing a couple people on Instagram. You're welcome to stay on Instagram. But I have pinned the YouTube link in the Instagram chat. If you want to see it in more of a widescreen, it's a little bit easier to see. You're welcome to stay on Instagram, but the YouTube is there for your convenience. So Yassine says no. Shiha says not sure about it. Damaler says no. Damaler, good to see you. Good to see you. Anybody else? Can you have a confusion matrix in unsupervised learning? That's the question right now. Just give me a yes or no. Or you can just say, hey, I agree with Yassine. I agree with Shiha. I agree with Damilar. Whatever you want. Anis says, I don't think so, as we have no labels, but I could definitely be wrong as I am learning. Okay. Thank you for the honesty, Anis. You know, we're all learning. We're all learning. I'm still learning, right? I'm still learning from all of you, so nothing wrong with that. Anybody else? Last call for answers. Can you have a confusion matrix in unsupervised learning? Fatima says it's not typically used in the same way as in supervised learning. Okay, anybody else? All right, last call for answer, guys. Another couple seconds here. All right, so the direct answer is no. You really can't have a confusion matrix when it comes to unsupervised learning. Why? Because we just said that there's no dependent variable. And if there's no dependent variable, and by the way, dependent variable is the same as our label, right? Then there's nothing to measure against, right? Because we're really not making prediction, right? So if we're not really making predictions, and there is no label that we can measure against, then the traditional metrics that we've learned previously kind of go out the window. They basically kind of don't exist for us anymore, right? So that's going to be one of the key things here. And, you know, somebody, I think it was Shiha, mentioned clustering earlier. And that's really kind of what we're doing. The best we can hope for is to have a clustering approach that encompasses as much of our data as possible, and makes the least mistakes as possible as far as how far things are from our centroids. That's really kind of like the best we can do. But when it comes to supervised learning, unsupervised learning, there is no more of your true instances and your false instances and your F1 scores and your precision and your recall. All of that kind of goes out the window because there's nothing to measure against, right? So what that also means, and as you're going to see today, is that it's also kind of it's a much more of a visual exercise. Because it's kind of hard to do clustering without having some sort of visual aspects to it, right? You kind of want to have some visual aspects to your clustering, right? So we're going to go over that today, all right? So let me go on to the next slide. So here, in this chapter, chapter 10, the authors present two different ways to go about unsupervised data. They present PCA, which is also known as Principal Components Analysis. And then they also present clustering approaches. More specifically, they talk about k-means, right? K-means is going to be our primary clustering approach, but there are other clustering approaches that are possible. Wait, did I get that right? Or did I... Hold on a second, guys. Let me double check myself. Yeah, it's k-means. Yeah. So that's what we're going to focus on for the k-means, okay? Or excuse me, for the clustering side, we're going to focus on k-means, all right? Now, I want to also give you a real world view because two things kind of struck out of me about this chapter. One, unsupervised learning is kind of it's definitely one of those data science things where it's half art, half science. There is no perfect exact way to do unsupervised learning. It kind of depends on you. It depends on your understanding of the data. It depends on the problem you're trying to solve. Things along those lines, right? So there is no single way to do it. So I'm going to try to give you some of that real world view of the things of how I've seen it done and how I've done it. You're welcome to do your own ways and explore your own ways. And maybe when you get out into the workforce, you'll be asked to use it in a different way. But I'm going to give you that real world view that I don't think the authors really present in this chapter. Okay. So there's two things that come to that as far as the real world. One, I haven't really used PCA a lot. There's really not a lot of instances that I've come across where PCA is needed. You know, if you think about the nature of PCA, it's kind of intended where you have limited information about the data. But in most cases, you're going to have some guidance on the data, mostly coming from domain knowledge, right? But I haven't really come across many instances where you know so little about the data that you need PCA. So that doesn't necessarily make it a bad thing to know. But you'll notice that I'm really not going to spend a lot of time on it. And you know, and I've always been honest with you guys, right? And I told you guys I like to stay in my lane. So I have done PCA so little in the real world that I'm not 100% comfortable teaching it. I'll give you the high level items. But again, from a real world perspective, I haven't really used PCA a lot. There haven't been many situations in the data that I've worked with that I've come across where you legitimately need a PCA approach, right? I'm still encouraging you to read the chapter, you know, don't skip anything, but that's just my real world view, okay? Second thing that I will tell you about, you know, kind of like the real world view. And again, this is something that the authors don't really talk about, but you do see some articles out there about this, you know. Some of the more advanced data scientists write about this because, you know, they've had the same experience in the field that I have. You know, as funny as it sounds, the most common way you're going to use some of these techniques, particularly the clustering techniques, is around taking unsupervised data, turning it into supervised data, and then creating a model, a supervised model from that. That's one of the patterns, one of the development patterns in data science. It's not really talked about a lot, but it happens. So you might be given a lot of unsupervised data, and then you'll be asked to do some clustering on that data. You know, you'll visualize the clusters in some way. Maybe you'll have to print them out, you know, because maybe it could be like an NLP problem or something like that. And then you'll rely on your stakeholders to name the clusters. And once you've named the clusters, then guess what? You have supervised data, right? And then you'll use that data to basically start all over again and create a supervised model with whatever other algorithm you want to use, right? It could be any number of techniques at that point. So that's a very common way to use unsupervised learning that people don't really talk about, but in the real world, it 100% happens. You know, you kind of use it as a bootstrap, right? To get into a supervised model. Like, you know, like a very common instance would be that you would have some very deep data, like hundreds of millions of records, right? That's unlabeled, which is obviously, you know, awful to work with. But you would take a subset, you would take a sample, do unsupervised learning on it, create your clusters, name those clusters, you know, and like magic, your clusters now become your supervised data, your supervised labels, right? Your supervised labels, and now you have the supervised data set, which is a representative sample of your bigger, you know, deep, big data collection, and then you use that to bootstrap yourself into a supervised model. I'm pretty comfortable saying that you're going to come across that in your career, right? So I'm sharing that with you for the understanding that unsupervised models don't really stay unsupervised models. They kind of become something else. Okay? Once we have some examples on the screen, remind me, guys, that I want to give you one other real world examples. I don't want to talk about it because it's better illustrated than talked about. But when we have some more charts on the screen, remind me that I want to share with you another real world example of how you would use unsupervised data. Because again, unsupervised data rarely stays that way. You'll usually be asked to do something else with it. Okay? All right. So you guys with me? Any questions? Let me know in the chat, okay? Otherwise, I'm moving on to talking about PCA just a little bit. Because again, guys, I'm being honest with you. I'm not 100% comfortable teaching PCA. I just haven't done enough of it in the real world, you know? So please read the chapter. Maybe the authors will do a better job of explaining it than I do. But I just haven't used it. I haven't seen the demand. So PCA. Basically, you can have these data sets. And some data sets you're going to come across are going to be very wide, right? You're going to have hundreds, if not thousands of fields in a data set. Do you need every single variable? Maybe, maybe not, right? There's usually correlated variables in those data sets, right? So when we're talking about the principal components, we're asking, what is the subset of all the variables when you remove correlation and all that other stuff? What are the variables that still provide you with enough variability of the data so that you can model on it, right? And as my last bullet shows here, the entire point of PCA is to reduce the dimensionality, right? Go from this super wide data set to a narrower data set and say, this data set is the smallest data set that we could find that still represents enough of the variability, the variance, and the diversity of your original data set so that you can run your data explorations on it. That's it. That's all PCA is. So when you hear principal components, it's referring to going from this wide data set to this wide data set, but still maintaining the verity of the variability in the original data set. So that when you do your explorations on this narrow data set, you can still be confident that you are coming up with something that properly represents the entire data set. And then that way you can do your explorations on it and still be confident that you're going to get results that reflect everything else that's in the data set. And that's it. That's all there is to PCA. Now, the authors get a little bit more into the math behind it, because how do you determine that it's proper variability, right? That's kind of like the key here, right? But there's libraries and code that will help you with that, right? I don't know if we're going to have time for that today, because there's other things I kind of want to explore. But that's really all there is to PCA, right? And I want you, and I'm like I said, I'm not 100% comfortable teaching PCA, so this is as far as I'm going to take it. But I wanted to share this with you because you probably are going to see this in interviews, right? You know, it's a common interview question, for better or worse. You know, people ask about PCA, right? But I think this is enough of an understanding for most situations where you're going to be using PCA, or at least enough to understand whether PCA is going to help you. Would you want to use PCA on a data set that has 15 fields, 15 factors? Maybe, maybe not, right? You can probably figure out the correlation yourself on that, right? That's not like a super wide data set, right? You probably want to reserve PCA for something that's significantly wide, right? So keep that in mind also, okay? But again, that's really as comfortable as I am teaching PCA, because I just haven't had the demand for it. You know, just being honest with you guys. So Phil HW says, thanks, makes sense. Okay, great. I'm glad that this is resonating with you guys. Thank you for that feedback, Phil. All right. Now, what about this other part? You know, and somebody else already mentioned in the chat, right? What about clustering? Well, clustering, I think, is very, very interesting, right? And you are 100% going to come across clustering in your work. So clustering asks a basic question, right? What are the observations in our data that are unique? Right? What are the general observations in our data that are unique? And then what are the observations of those unique ones that are close together, right? That's basically like the definition of a cluster, right? A cluster overall is unique, but then the data points within each cluster are similar to each other, right? Otherwise they wouldn't be in the same cluster. So basically we're talking about segments, right? Each cluster represents a segment in our data. So I mentioned segments because that's also beneficial to think about from like a marketing perspective, right? Or like a customer segmentation perspective, or a sales perspective, right? Because you guys know I always emphasize the business side of everything we do, right? So, you know, it's kind of important to think of it in those terms also. Because you don't want to talk to your stakeholders about clusters and your centroids, and you want to talk about the market segments of your customers, right? So that's why I also mention that. So in this chapter, the authors choose to focus on k-means, which I think is great. K-means is definitely the most common factor algorithm that you'll come across, right? Because k-means is pretty powerful for just about every instance out there of data. You'll find others. There's other clustering approaches, but k-means, you know, is going to get you pretty far for most of the things that you need to do. Okay. And I also want to emphasize, don't get k-means confused with nearest neighbors. Because if you guys remember, if you were here for that class, we saw nearest neighbors when we were talking about some of the beyond regression methods, right? Nearest neighbors only works for supervised data. K-means is primarily used for unsupervised data, okay? So very similar names, right? They both focus on centroids, you know, in the centers of those clusters. But k-means is what we'll be focusing and what you'll use in unsupervised data scenarios. All right? Everybody with me on that? And also, I want to make it clear that what I'm presenting here This is my interpretation of what the authors present, right? Because you guys know I always go in, I go to the chapters and I pull out the important parts of the chapters, right? So this slide is how the authors present it in chapter 10. So the challenge with k-means clustering is that you never know how many clusters there should be ahead of time, right? So again, if we're talking about like your customer data, right? And you want to know about your different customer segments. How many customer segments should you have? Who knows, right? Do you have 10 segments of customers? 3 segments? Like, you never know, right? So that's where the challenge of k-means is. How do you know how many clusters to have? I mean, when you really get down to it, each single observation could be a cluster, right? You could have as many clusters as you have observations in your data. Like, why couldn't you say that every single piece of data is unique? You could, right? But of course, that's not effective, right? So that's the biggest challenge that you should think about. Because, even if you think about the answers everybody gave initially, right? Well, we're trying to, cluster our data. We're trying to segment our data. It's unsupervised. It's unlabeled. Well, how many labels should you have? How many clusters should you have? Who knows, right? The only thing you really know is the maximum. The maximum is the number of observations you have. But again, that's not practical, right? But beyond that, you really don't know. So that's a big challenge for k-means. So I want you guys to remember that. Okay. And again, on this slide, I am presenting what the authors tell you in chapter 10. Okay. So on this slide, you'll notice that I've highlighted. I say that these are my notes, not the authors. Okay, because I don't want to put any words in the author's mouth. But I will say that the authors, I think, could have done just a little better of a job explaining k-means. Because k-means is actually a 2-step approach. We are going to do what's known as an elbow diagram to help us figure out the optimal number of clusters that are needed for a particular k-means problem. All right? Because an elbow diagram helps you figure out the number. If you remember, guys, the clusters, the centers, right? The Ks, the number of Ks are known as centroids, right? So determining the number of centroids is very key. And the way you determine that is by trying different centroids and then figuring out at which number of centroids you are capturing the largest amount of the variability of the data that you can. That's essentially what you're doing, right? How many centroids does it take to remove that variability? And what you'll see is that it's called an elbow diagram because initially, if you just use one centroid for all of your data, there's a ton of variability, right? There's always going to be a bunch of outliers that you never quite get. 2 centroids, okay, now you're catching more variability. 3 centroids, that's a lot better. 4 and you try it over and over again. But at some point, using 7 centroids, 8 centroids, it gets to be too much, right? Because now you're approaching having a cluster for every single piece of data, right? Where every observation is a cluster. So there's a diminishing return there in the number of centroids that you use. So based on that, you're gonna say, okay, the elbow diagram says that after X number of centroids, let's just use 5. After 5 centroids, there's very little gain in capturing more of that variability. So you want to use the number of clusters, the number of centroids that reduces the variability, but doesn't go into that part of the diminishing returns. So in other words, the elbow, right? Where that diagram flattens out, that's known as the elbow. And you want to choose the number of centroids that are at that elbow, okay? So if that's a little confusing, that's okay. Again, this is a very visual chapter, right? So we're going to spend some time with ChatGPT. We're going to start generating some diagrams and start seeing where it goes. Okay? All right. Let me check here. Okay, yep. On the next slide, we're going to code, guys. So if you have questions, please let me know in the chat. Let's get those questions out before we go to code, okay? Mafood waves hi. Hey, Mafood, how are you? Good to see you, my friend. All right, any questions, guys, before we go to code? And just as a reminder, because I know we have some new people, here's our framework, right? What is the result that we're optimizing for? That's what we should always decide as data scientists. What does the code look like for all of this? And remember, we're accepting that AI is going to be part of our future. So we are going to be level 2 data scientists prompting an LLM for assistance. That also means that we are going to be code editors, not code writers. This is the way of the future, guys. And I have a whole video on this that I just released this week. Right? Don't be a dinosaur that's just chewing on plants, thinking those plants are going to be there next year. They're not. The data scientist of the future uses AI and accepts that AI will be a massive part of how we work in the future. Okay? So that's going to be our framework for what we're going to accomplish. All right? Okay, so Yassine asks, and put your questions in the chat, guys, before we go to code. Would be a good approach to use dimensionality reduction techniques to visualize the data, then get some ideas or assumptions about the number of clusters. Sometimes. Again, depends on dimensionality. I mean, look, guys, one of the things you're going to find, or at least it's been my experience, is that companies are terrible about why data, right? You are not going to come across multidimensional data nearly as much as you think you are, right? Companies are really not great at that, right? Especially if you're all, well, I shouldn't say that because it's not exclusive to know it. I was going to say that it's related to the NoSQL databases, but that's not accurate. That's not accurate. Yassine says, would it be a good approach? You can, Yassine. It's just not something you're going to come across as often as you think it is. Okay? But yes, if you wanted to reduce it down prior to your clustering, you could. You could, assuming you had a significantly wide data set. Sure. All right, last call for questions, guys. Otherwise, I'm going to start prepping our environment up here. So another thing, guys, again, because I know there's a lot of new people. We work with a professional mindset, which means that we do not use notebooks, right? Notebooks is not how you do professional data science. Professional data science is all done with Python programs. So I would encourage you to move away from notebooks as much as possible and start working on writing Python programs and not scripts. That way you can develop yourself into more of a professional developer. So we are working with Visual Studio Code, and then we are also working with a simple terminal window, and we are running everything locally. And basically we are, just trying to focus on having a professional approach to our data science development. Okay. So I have set us up with a plots file because I think we should plot out some data and then just start working with it, right? Just like we did last week. We're going to ask ChatGPT to generate a data set for us and then go from there. Okay. All right. So let's bring up our good friend ChatGPT. And again, if you guys need me to blow anything up on the screen, let me know, okay? And I will adjust. We're going to ask for 500 observations just to kind of, just keep it a healthy data set. See, 500 observations. We're going to ask for multiple features. And please save the data to CSV. And I also want to see a plot with the observations and also save the plot. Yeah, let's see what this gives us. Okay, so it's using scikit-learn. It's using matplotlib, well, pretty reasonable choices. Gives us a scatter plot, gives us the observations plot, saves unsupervised data. All right. Let me bring this over so make it easier for you guys to read. What do you guys think? I think it's pretty reasonable code. Anybody else have any observations on this code? I mean, it's using pandas, uses NumPy. It's gonna use the make blobs function of sklearn, scikit-learn. Looks pretty reasonable to me. What do you guys think? Anybody want to give their thoughts? Well, let's pump the brakes there, Cyberlytic. First of all, don't spam my chat, okay? Second of all, pump the brakes, right? We can't just run code that ChatGPT gives us. That's irresponsible. That's not a professional mindset. You should still supervise it, right? So what do you guys think? Daimler says it looks good. Yeah, I think so too. I mean, it seems reasonable as far as the selections that that ChatGPT made. Oh, Cyberlytic, come on, that's a terrible follow-up question, dude. How can you spam my chat 4 times or run the code and then you ask what the objective of the code is? Dude, bad form, my friend. Bad form. You can't do that. You can't just flippantly run code on your machine. That exposes a security risk to you and your company. Bad form, my friend. Bad form. Yassine says, looks good. It's using 2 features, so it's visualizable. Yeah. I mean, I think it's reasonable, right? Let's see what it gives us. I think it'll give us a similar plot to what we saw last week. So I'm in my terminal. Let me just make sure the file is there. I think I'm in the right terminal. Yep. So Python plots.py. That looks like it's still running. Hasn't given me a plot yet. Ma says it's not predicting anything, it's just a simple visualization. Yeah, but that's by design, right? That's by design. We want that. We haven't gotten any data to work with, right? That's what we're doing now. All right, guys, so here's the plot. Let me bring this over. Crazy Susie. Yeah, Crazy Susie, I like the way you're breaking this down, right? We are using pandas to handle data and Matplotlib to visualize it, although I'm not aware of the sklearn datasets library. Yeah, I'm with you, Crazy Susie, but you know what? You're describing it accurately, but you're also describing one of the benefits of ChatGPT, right? ChatGPT is supposed to kind of expose you to new methods and functions and even libraries that maybe you didn't know, right? I mean, ChatGPT is your employee now, right? So yeah, that's kind of what I'm totally okay with it showing us a new library, right? All right, but here's a scatter plot, right? What do you guys think? M. Shaban says, you do these lives daily. I am a new follower. What's the purpose? The purpose is data science. You know, I'm passionate about data science and I like sharing the real world experience of it. On Sundays, we happen to do more of an instructional content, which is what we're doing today. We're finishing up our study of the Introduction to Statistical Learning book. But other days, I do kind of like an AMA style where people can ask all types of questions. So feel free to stay. Feel free to go to YouTube if you want to see it in a little better format. But the purpose is data science. That's kind of what we do. Okay, so what do you guys think of the scatter plot, right? Remember, we've talked about this. We talked about the kind of like the pattern recognition that you will develop over time, right? Right? That's kind of the purpose of the experience of data science and also kind of why we plot things out, right? So just give me your general observations, right? What do you guys see? Your stakeholder just gave you this data, right? You're in early stages. What do you guys see? Tell me. How many clusters do you see? Okay. Yassine says the scatter plot implies the existence of 3 clusters. Rohit agrees, says 3 clusters. Okay. All right. So I'm not going to ask for more answers there because, it's obvious that there's kind of 3 clusters, right? But let me ask you guys this now. Okay. Crazy Susie says, I feel the result is clustered and quite difficult to understand or analyze from it. Okay, Crazy Susie, let's get to that. I read your comment because it's a perfect segue into my next question. Okay? I think we're in general agreement that there's 3 clusters. I mean, that's fairly obvious. Are they good clusters? Not every cluster is a good cluster, guys. Are the 3 clusters good clusters? Think about that. Give me an answer in the chat. Okay, Yassine's already onto it. Yeah, but one is like more unique than the other two. I don't know if I see that, Yassine. I don't know if I see that. I see a cluster that's going to have more variability than the others. And maybe that's what you mean by uniqueness. But I see a cluster that's going to have more variability. Ma CH says, like clustering. Yeah, this is like a clustering exercise, sure. Right? I mean, that's really kind of the only thing you can do with unsupervised learning, right? Okay, Rohit says the one at the bottom is good, but the upper two seem kind of mixed at the boundaries. Okay. All right, so look, if you want to participate, maybe you're shy. You don't have to give your own opinion. You can just say, I agree with so-and-so or whatnot, right? I'm holding back some of my thoughts because I don't want to bias all of you guys. But what do you guys think? And by the way, I'm doing this because this is an important part of the scientific process. You got to talk things out. I see it this way. Oh, you see it that way? Why? Why is that? What are you seeing that I'm not? Super important part of being a scientist, guys, okay? Any other observations? Or you just want to say, hey, I agree with Yassine, I agree with Rohit. Let me know. Andy says the bottom cluster will have more variability. Okay. Andy, I'm liking that observation. Yassine says, I think the bottom one is more sparse, so that has to mean something to how healthy it is to consider it as a good cluster. Okay. Anybody else? Last call? Manoj says, agree with Yassine. Okay. Okay, yeah. I think we're all seeing kind of very similar ways. Ma CH says, which algorithm we use in this if we work with something? We haven't gotten there, Ma. We're still working on it. Pump the brakes. Let's pump the brakes over there, guys. And these Instagram folks today. Let's pump the brakes. Let's take it one step at a time. There's a methodology to data science, right? Right now, we've just received the data from our stakeholders. That's all we've done, right? So this is us just doing EDA, right? And it's more of a visual exercise at this point, just to kind of see where we're at. All right, so everybody pump the brakes. Andy says the bottom data points are more spread out. Yeah, I think you said that before, Andy. So yeah. Obviously, there's 3 clusters. There's going to be some interesting decisions to be made here at this kind of border point, right? As somebody mentioned, there is a lot of overlap or potential for overlap in these 2 clusters. But this is the one that concerns me a little bit more, right? Because the centroid of this cluster is fairly obvious. It's going to be somewhere here. But it's pretty wide, right? It's a pretty big cluster. So does that make it a good cluster? Maybe, maybe not, right? These up here I'm a little less worried about because, they seem like a little bit tighter cluster. But you are going to have some overlap there, right? But we'll talk a little bit more about that overlap, right? We're gonna get to that. We're going to get to that, right? But really, again, the win here, the point here, is that you should be going through this to kind of understand where your overall study is going. It's very healthy for you to do this and be able to say, okay, yeah, I'm kind of seeing this, kind of seeing that, just Your observations as a data scientist are still, let me take a step back. As mathematical and as formula oriented the world of data science can be, as I said earlier, unsupervised learning is half art, half science. So this is the art side of it, where you should still be plotting these things out and saying, okay, yeah, this is kind of where it's headed. You know, my gut tells me this, right? You know, my eye is telling me this. You know, my experienced eye is telling me, because I've done hundreds of these, right? Super important part of the process, guys. It's unsupervised learning, again, half art, half science, okay? Forever Never says, are they considered outliers? We'll get to that. We'll get to that, okay? I promise you we'll get to that. Okay, guys, so we have our data, right? Now, in this particular data set, we know that there should be about 3 clusters. But it's not always going to be obvious, right? And for all we know, we're wrong. Maybe there should only be 2 clusters. Maybe it should be 4 clusters. So we want to put some numbers behind that. And this is where that elbow diagram comes in, right? So let's do that. That's our next step, right? So let's go ahead and move on from this data set. But obviously we save this plot, so we can always come back to this plot. Let's get a new file going. And we're going to call this elbow.py. And let's work on that elbow diagram. Because again, unsupervised learning, 2-step process, okay? 2-step process. The authors, I think, could have done just a little bit of a better job in illustrating that. So we want to be explicit that we want to use the existing data, right? So please use this data and then show me the code to create an elbow diagram. And also, all right, so you see that? It brought in the k-means library right away from scikit-learn. So pretty good chance that we're on the right track here, right? Yep, okay, cool. Let's take this over to make it easier for everybody to read. All right, so I think the top is fairly straightforward. Oops, save. The top is fairly straightforward, right? Pandas, scikit-learn, particularly using k-means, which is no surprise, right? We just learned that. And, you know, our plotting, using our same data set, right? Unsupervised data CSV. Okay, so here's where the good stuff begins, right? So remember, k-means, elbow diagram, sounds pretty sophisticated, right? But as I said earlier, the only thing it's doing is it's almost like a brute force, or like a Monte Carlo, right? It's saying, okay, what does the diagram look like if I use one cluster or 1K, right? The centroid. What happens if I use 2? What happens if I use 3? And so on. So you can see here, that's what we're doing here. We're just establishing the range, right? That's it. That's all we're doing. And then here it's using the squared distances because that's how it measures. Okay, so if I use 1 centroid, how far am I from all the points? Okay, that was terrible. 2 centroids. Okay, 2 centroids, I can capture more points. 3 centroids. Oh, now I'm even closer to all the... And so on, right? So there's really not a lot of magic to it. It's more of a brute force, you know, underneath the hood, right? You know, even though in the book you're going to find a lot of fancy formulas and things like... You're just trying different centroids. That's all it is. So that's what you're doing here. We're going to say that we want to max out at 11. And here's where you're running it, right? You're saying, here, I want to use k-means. I want to use this number of centroids. And, we always maintain a random state as we've seen in other code. And then you're just plotting the elbow diagram, right? What does it look like at the different centroid levels? So in this scenario, the x-axis on our centroid diagram is going to be 11, right? 1 through 11. Because it's going to show us this is what happened with 1 centroid, 2, 3, 4 to 11 centroid. Okay? So some of you might be wondering, well, how do you know that you should only try up to 11? So that's something you really don't know, and it's almost kind of like an experimentation thing, right? But I will tell you that the wider your data set is, right, or the more sparse your data set is, the higher you should be trying for the cluster range. In our scenario, we're probably fine with 11. We've seen the data, we've applied our expert eye. So we know that it's probably not going to be anywhere near 11, right? And the elbow diagram will kind of prove that out. But just keep in mind, in the future, guys, the more sparse and also kind of like the more data points you have, the more you're going to want to try out to 50 centroids, 80 centroids, things along those lines. Okay? So just keep that in mind. But otherwise, I think this looks like fairly reasonable code. Anybody else have feedback on the code? Wow, let me look at the chat messages. Forever never says consistent frequency. Yeah, in this example, there's some frequent or some consistent observations, but that's not always the case, right? Rafine, I think this is your first time. Welcome, Rafine. I am into intro stat class. I can already say I wish he was this detailed in explaining what's happening in the application. Thank you. I appreciate that. I think that's a compliment. Whenever says he's assessing a population. Yeah. I mean, that we should be doing that. Okay, but he's pointing out the individual results and informing us on what's happening. Usually we're taught this is a scatter plot, and this is what it does, and move on to the next graphic chart. In addition to how we should think when it comes to assessing the scatter plots. I have to go, Dennis, but I will try to post and make stay informed on your upcoming lives. Well, thank you for that. Again, one of my strengths is I'm able to explain complex things. So yes, I am trying to take the time to explain it to you guys, and I also give the real world view. So I appreciate the compliments. Thank you so much. Okay, so Yassine says, sir, if I may ask a question, I think the algorithm produces data with 5 features, or for the plots, it chooses randomly 2 to plot. So how reliable is the plot for assessing the cluster? You don't know. It's totally fine to go ahead and try other features, right? You could definitely do that if you wanted to. You could also involve the PCA items that we talked about to determine which ones you should be plotting, right? You could also be using a lot more domain knowledge than we're using here, right? Here, the data doesn't really mean anything to us, right? It's synthetic data. But you could be using some domain knowledge from your stakeholders to help you. You could be doing that, right? But look, Yassine, I mean, I'm sure you're smart enough to understand that we're walking through examples here, right? How you want to apply them in your individual practice, your individual problems that you're going to come across, right? That's up to you, right? But I have to show you at least one example to walk you through it to enable you to move on to other things, right? So let's just keep on going with this, but you're welcome to do whatever features you'd like, okay? All right, so I think this is reasonable code. Let's go ahead and run it. So this one was called elbow.py. Let's see what this says. All right, we got a bunch of warnings, but no errors. It's telling me that I can suppress the warning, so that's okay. And here's the elbow diagram we got, guys. That is super interesting. That is really interesting. Wow. What do you guys see? First of all, do you see the elbow? Do you see why this is called an elbow diagram? You might be new. This might be your first time seeing an elbow diagram. Do you see why it's called an elbow diagram? Just give me a yes, no. Do you see why it's called an elbow diagram, guys? All right, for Never Never says yes, they see it. Okay, anybody else? All right, Crazy Susie sees it. Okay. All right, so you guys are seeing the elbow diagram. Now, in the chat, can you interpret the elbow diagram? What is the elbow diagram telling us? Does anybody want to take a turn at interpreting the elbow diagram? Remember, the elbow diagram is supposed to guide us on how many clusters we use, right? Anybody want to take their turn at interpreting? Yeah, Daimler, you're right about that. But what's the next step? What is the what is our learned what is our takeaway from this diagram? Yassine says from four clusters above the evolution is very small, so maybe it's suggesting that the K should be 4. Yeah. Yeah, I mean, Anis and Daimler, you're giving me good definitions, but what does it actually mean, right? Like, give me the takeaway. And the takeaway, Yassine is right. It's 4 clusters, right? The elbow diagram says that 4 clusters is where you should be at. Now, let me bring up the previous chart. I don't know if I think I can. Let me go back to the previous chart, the observation. Remember this chart? That was the observations we had previously. And we all kind of agree that it's about 3 clusters, right? But the elbow diagram, and again, this is why we do this, right? We do this to say, to verify our assumptions. And this is telling us that our assumptions are wrong, that there's actually 4 clusters here, according to the elbow diagram, right? So does anybody see 4 clusters? I have a gut feeling about it, but I want to hear it from you guys. What do you guys think? So Susie, I'm going to disagree with you. This is telling us that at 3 clusters, you're doing pretty good, but at 4 clusters, you're still gaining a benefit. Because remember, guys, the y-axis is as a measure of errors, essentially. The square distance of errors, right? So this is telling you that at 3 clusters, you're doing pretty good in reducing your errors, because 1 cluster stinks, right? 1 cluster, you're getting a ton of errors. 2 clusters, you're doing better, but still high. 3 clusters, you're doing great, but this is saying that 4 clusters, you gain more. So the elbow is actually at 4. The recommendation is 4, because after 4, you could be using more clusters, but you're not gaining nearly as much, right? So yeah, so you're almost on the right track, but the elbow is actually at 4, not 3. Okay? Andy says, why have you settled on 4 clusters? What is it that you see? Because again, the Y scale, right, is a measure of errors that you're making. So you should, obviously we want to try to minimize the number of errors that we're getting, right? So we're doing that at 4, according to this. After 4, you're basically at the same level of the number of errors. Andy says, is the y-axis a margin? It's not a margin of error, but yes, it's a measurement of error. Yes. So that's why you want to pick the lowest point along the y. Okay? Okay, so Satyam says, yes, on the down cluster, I see 2 by dividing from the middle. Okay, so you want to create 2 different clusters here. Okay, that's not wholly unreasonable. I can see why you would say that. Okay. All right, so that's I'm sorry, I didn't highlight that message. So Satyam says that, right? Satyam sees that this cluster, the bottom cluster, can be divided into 2. All right, I like that. So Satyam, I like your view here, right? Because again, talking this out is part of the process, guys. I thought that maybe there's a potential for a cluster between these 2 in the upper section. Remember how we talked about how there's a lot of overlap here? Well, why can't we just make that its own cluster, right? Wouldn't that reduce the variability? If we agree that these are kind of far from their centroids, then just make a cluster here and make it its own centroid, right? So that was my thinking, right? But Satyam could be right, So this is us sitting in the team room, going back and forth and saying, oh yeah, I didn't see that before. I see the 4th cluster up here, but yeah, maybe there are 4 clusters down here. This is a super important part of the process, guys. All right, don't be afraid to talk things out. A very important part of the process. So Yassine brings up an important point. The elbow graph takes into consideration all the features. Couldn't that be what explains the difference between the results? Maybe. Sure, that's possible. It's possible. But again, it's more unsupervised learning, half art, half science. So it's a visual exercise. So I'm really excited to see where the 4th cluster is actually going to be, right? We're going to ask it to plot it out right now, right? That's the natural next step, right? So let's find out. Let's find out, Yassine. And also let's find out if Satyam's right. Satyam sees 2 clusters down here. That's a unique observation. I can appreciate that, Satyam. Right? So anybody else want to give their predictions or their view on where the 4th cluster is? Last call for predictions on that. Anybody else? Forever never says 0. Okay. I don't know if that's much of a prediction, but all right. So let's go to the next one, right? So we need a new file, and this one we're gonna call our k-means file, right? Now we're actually ready to do k-means. Oh, whoops! I k-means. All right. Actually, let me close out some of these plots. Let me close out this plot, and then that should finish that one out. Yep. And then let me clear that out. Okay. Now we're going to start with another blank slate. Go back to our good friend ChatGPT. So now we know we should have 4 clusters, right? I want to use k-means for 4 clusters, and please create a plot that shows the clusters, and both show me and save the plot. All right. Yeah, this looks pretty good. You guys will notice that the code is a lot briefer this time, right? And that should be expected, because now we're giving k-means more guidance, right? We know that there should be, we're asking it to do 4 clusters, right? So when you do that, it's going to go ahead and just go straight to that answer. It doesn't have to do like that brute force that we were talking about earlier. You'll notice that it's using the same k-means a method call that we used earlier, but this time it already knows the number of clusters. It doesn't have to try 1, 2, 3 all the way to 11, right? So to me, this looks fairly reasonable because it should be brief code. And also remember, like I said, k-means or unsupervised is a 2-step process. Elbow diagram and then your k-means. We've already done the first step, which guides our second step, and this code is the result of that. All right? So I think this looks fairly reasonable. Let's try it. So let's make sure our file is there. I believe it is. Yep, and I called it k-means, so Python k-means.py. Wow. Oh, this is so interesting. Wow. Look at that, guys. Wow. Oh, I love it. I love it. Okay, now who was my bottom cluster guy? Was it Satyam? Okay, Satyam. Satyam, oh my gosh. Give me an honest answer, my friend. When you said dividing the middle, did you mean horizontally or vertically? Because I thought you meant vertically. I gotta be honest with you, I thought you meant vertically. You saw it horizontally. Interesting. Interesting. Okay. See, so that's my fault. I should have clarified that because I thought you meant horizontally. I could have seen it horizontally, right? Because you still have these outliers out here, right? Horizontally, to me, captures it a little bit better because you're moving the centroids, right? Rex says, I couldn't have predicted that clustering version. Rex, I'm with you, man. I did not see that either. I'm with you. Okay, Satyam says they saw it horizontally. Yeah, I saw. Okay, Satyam, no, you're right. I did not see it horizontally. Ranjat says vertically. Ranjat, I agree with you. I saw it vertically. I saw it vertically too. That's crazy. That's crazy. But again, guys, this is why we do this. This is why you go back and forth, right? And also this is why you do the exercises, because guess what? Our assumptions were incorrect. There aren't 3 clusters, there's 4. And that 4th cluster may not look like what you think it should look like. Remember, for me, my guess was up here somewhere. Why is this not a cluster, right? If you made that a cluster, you take a lot of the variability out there, right? So this is interesting, guys. This is why we do the process, right? Now we're going to give Satyam credit, assuming he's being or they're being honest, right? But Satyam was the only one that saw that, right? The horizontal break, not the vertical break. A couple of us are saying, hey, we saw the vertical break, right? Rex says, would we need to repeat and see if it gives us the result? No, Rex, because the data is the data, right? And this is what our work, our mathematical work behind the scenes has led us to show that this is the number of clusters that minimizes the errors, right? Now, what we can do is we can, as we said, we know that at 4 is where you start getting the best results. And there's only slight improvements after that, right? So the more interesting exercise is to start trying 8 clusters, 10 clusters, seeing what that looks like. Because in theory, that does get more accurate, just not as much as going for 3 clusters, right? So we could try it, but it kind of becomes a different exercise in that way, right? Satyam says, I saw the clear gap in between the cluster. Yeah, but a lot of us saw it vertically, not horizontally though, Satyam. Right? So people are going to see things different ways, and that's okay. But again, this is why we do this, guys. All right. So earlier, I told you guys that when we had some charts up on the screen, I would give you another real-world example. Okay. So here it is. Something for you guys to think about. Okay. So this is our client data, and we followed our elbow diagram. We know that our optimal result is 4 clusters, and we know that this is what it looks like, right? We know these 4 clusters. So let me ask you this. What would it mean if we had a result that was out here? Or a result that was out here? Or a result that was out here? Give me your thoughts on that. What does it mean if we were to have a data point out here in this corner, or out here, like near where the number 5 is, like right next to that, or down here in this corner? What would it mean? Let me know in the chat. I'm going to give you guys a minute to think about that. All right? And while you're thinking about that, let me give you another extra thing. A lot of you are going to be tempted to give me the data science explanation. But if you want extra credit, give me the real world explanation. Okay? All right, I'm already seeing some answers come in. Outlier, extreme outlier, scattered chart, inaccurate error. All right, anybody else? Or you just want to agree with somebody? You can do that. And remember, I'm asking this because I'm telling you about the real world side of this unsupervised learning, okay? Yassine says it's an anomaly, okay? Ranjat says, can we do feature engineering on the data set outliers may exclude? Maybe. But do you always want to exclude outliers? Maybe, maybe not. Outliers are still data, guys, right? Your goal should never be to like fully eliminate outliers. Data is still data. For Never Never says, is it more comfortable to generate these codes on Linux in comparison to a GUI? Not necessarily, but this is how it's mostly done in professional environments, right? Professional environments don't always have a GUI, right? Professional environments, you're going to be asked to work on Linux. You're going to be asked to work in distributed systems. You're going to be asked to work in, load balance systems. It's just easier to work in scripts and programs. All right, so outlier, extreme outliers, scatter chart, inaccurate error, anomalies. You're on the right track, right? But why would I bring this up when I was telling you guys that I wanted to give you another real world example? Think about that, right? And again, guys, this is kind of like, these are the steps that I really want people to take away from my content, right? Because I try to teach real world stuff, right? What does it mean? What does it mean? It's possible cluster that's not targeted, like we don't cover. Okay. Okay. You guys are inching up on the answer. Like where it's missing that possible type of clients. Okay. Okay. You're getting a little closer. You're getting a little closer. All right. So what if excuse me, guys, sorry. What if I were to tell you, because remember, we haven't really talked about what this data could represent, right? Oh. Excuse me, guys. We haven't talked about what this data could represent, right? So what if I were to tell you that these are 4 different classes of credit card transactions? Right? We know that there could be 4 different types of credit card transactions. Like let's just talk about value versus location, right? Those are our features, right? In this location, we have this value. In this location, we have this value, and it comes out to 4 clusters and all that, right? Forever and Ever says insignificant sample. Ooh, no. Be careful with that. Be very careful with that. And Yassine has hit it, right? The other one is possible fraud, and that's exactly right. That's where I'm going with this. We just developed a fraud model, right? This could be your fraud model. Because you just went through an entire exercise with all this data to say that all of these observations fall in these 4 clusters. So when you have an observation out here, that should ring alarm bells, right? Or you have an observation down here. Why did you not fit into the 4 clusters that you just determined? Massive alarm bells should be set off in your systems. It's a fraud model. You're looking at a fraud model. Whether you realize it or not, we just developed a fraud model. Why is that credit card transaction out here when 10 million cluster or 10 million pieces of data fit into 4 clusters. Isn't that a concern from a business perspective? A massive concern, right? So yeah, I like the way you guys were creeping up on the answer, right? And Yassine got it there, right? It's a fraud model. You are looking at a fraud model. You just saw everything we went through, right? We just went through all these examinations, and we did it by eye, and then we did our diagrams, our elbow diagrams, and then we charted it, with the actual number of k-means, with actual number of centroids. So why is there an observation out here? Why is there an observation out here? This could be your fraud detection model, right? If the transaction comes in and I can't fit you into one of the 4 models, red flag, right? So that's the other real world example that I wanted to give you guys. This is where unsupervised data can be powerful, because it can be a model for those types of things. Because again, right, we live in an unlabeled world. A fraudulent transaction doesn't tell you that it's fraudulent. You have to designate it as fraudulent. Your model has to designate it as fraudulent. So this is it. You have the ground, the foundation here for a fraud model. There should be 4 clusters. So why does this transaction not fit one of my clusters? And then if you really want to get fancy with it, another thing you can also do is you can start looking at the data points that are far away from your cluster centers, right? Because this is your centroid. So why is this one out here? That gets a little bit more nuanced, because there could be like domain knowledge reasons why, or domain expertise reasons why, and it requires more back and forth with the stakeholder and all that. But when you have something that's out here and doesn't fit your existing clusters, red flag. All right. So I'm glad I'm seeing some of the chat, and I'm glad that you guys are catching on. But yeah, I mean, this is also a valid foundation, a valid framework for a fraud model. Okay. So never, what is your name? For never ever says not a normal population. Yeah, but you want to know about those, right? You want to know what doesn't fit your 4. If we're defining the 4 clusters as your population, you want to know what doesn't fit your population, right? Like, you want to highlight those in some way. Michael says, hello, Sir Dennis and everyone. Late today. We'll watch the replay. Michael, so good to see you. You're such a great supporter. But yeah, Michael, I think you've been here from the very beginning. So good to see you, my friend. You're here at the end too. I really appreciate you, man. Appreciate all of you that have been here for all 8 classes. I still can't believe we're done here. But yeah, as Michael points out, if you missed any of the classes, maybe you had to leave early or whatever the case may be, the replays are on YouTube. Once I finish this, I'm going to sit here and I'm going to do all my editing, so that I'll get session 8 out today, which means that the playlist of all 8 sessions will be complete. And then I'll have a complete loop that has all of the sessions again. And that way you guys can, watch it and come back as you want and all that. So, I'm going to make this class available to you because, again, guys, this is part of my legacy. Like, I've shared this before, but like, in a way, I'm a little bit humbled that I've been able to teach this book, because when I first read this book, I was so intimidated by it, right? Like, it's such a complex book, and I learned it at the graduate level, so I knew it was a serious class, and so for me to be teaching it, it's like, wow, it's pretty cool. So Satyam says, whoa, mind blown. Yeah, Satyam. So I kind of walked you guys into that, right? Like, this is a fraud model, right? You could be using this as a fraud model. I've done this, I've done this for clients where you can figure out, like, I want to know about what doesn't fit my previous patterns, right? Like, I want to know when something isn't going right, when you can't classify something, right? When you can't, and by classify, I mean in a cluster, right? And then Ranjot says, got it. Okay, good. I'm glad this is resonating with you guys. Okay, so I think this is the last item I want to leave you with. Remember how we talked about how unsupervised can become supervised learning? So that's where we're at here, right? Because now we know what our 4 clusters are. And now we know the members of the cluster, right? So are we not also looking at a supervised data set? We are, right? We can go back and we can say, hey, this centroid, I'm going to call this centroid this, and I'm going to call this centroid this. And you can label each one of these centroids, and then you know the members of each centroid. What observations belong to which centroid. Is that not supervised data now? It is, right? We have 4 potential labels, 4 potential categories, as we've seen in other things, and we can use other things here. We could take this and now start using a neural network. Neural networks are great for supervised problems, right? We can use a neural network and say, here's my supervised data, and go to it, right? So you also have the foundation here for, like this is the bootstrap, right? This is where the bootstrap ends into supervised data. And then you start the process all over again. You're going to have to do a proper champion model search, and maybe even, you will have to do EDA again, right? Because now it's a whole new data set. Now it's labeled data, it's supervised data. And you can start to use that. And you will come across instances where you do that, right? So you're kind of getting a 2-for-1 here, right? You could stay here, and this is a totally valid framework to develop a fraud model, right? Or you can go on and do a supervised model now, because now you have supervised data. It just leads back to the whole thing about how most unsupervised approaches are kind of like these deep data explorations, right? We've made it about clustering, but it's really, but the meta view is that you're really kind of learning about your data, right? And then also shout out to, ChatGPT, it gave us totally reasonable code. It gave us great data, right? We started with our plots and generating the data. It gave us great code for the elbow diagram, right? And the elbow diagram kind of broke some myths, right? It broke some of our assumptions. Excuse me, sorry. It broke some of our assumptions. All of us had kind of agreed on 3 clusters. Guess what? We were wrong. That's why we do experiments, right? Right? I mean, we laid out a thought that yes, it was, looked like 3 clusters, but you got to carry out the experiments. Got to validate assumptions, right? And then with k-means, some of us were surprised by how many clusters were out there, or how the clusters were developed, right? But, the end result is this chart. And now we're ready to do other things with it. We have a fraud model. We can bootstrap this into supervised data. Lots of things we can do. All right, so I think that should give you a pretty good understanding of where we're at in terms of unsupervised data. All right, any questions, guys? Because that really covers everything I wanted to leave you with today. And basically I'm saying that I'm covering everything I wanted to leave you with from this book. So obviously I'm not going anywhere, I'm still going to be streaming, but this does kind of conclude the book portion of these Sunday instructionals. I have plans for these other Sundays, I'm developing some other ideas. But any other questions, guys? ChatGPT performed flawlessly today. We got to give it credit. It gave us a lot of really good code. No errors today. But yeah, I think that should give you a pretty solid understanding of where we should all be with unsupervised learning. Any last questions, guys, before we wrap up? Yassine says, thank you very much. It was a very insightful journey. Thanks a lot for your efforts. Yeah, thank you too, Yassine. I know you've been attending quite regularly, so thank you so much. Rex says, it's been a great series to watch. We'll definitely come back to these lectures, study them again. Thank you, Dennis. Thank you, Rex. I appreciate that. Yeah, you've also been here every class and really for the entire length, so thank you so much for that. So yeah, guys, at this point, it's going to be, I think, like 20 hours of content for this class. So it's going to take you a while if you want to go through everything, right? So, I encourage you to watch it. And remember, guys, it's not about job searching. It's not about keywords to pass the recruiter. It's not about quick jobs. Apply yourself to be a professional in the field. If you do that, everything else will come easily, okay? It's not about passing the interview. It's about being ready to be a professional. And I really hope that, this series has kind of taught you that, right? To build that foundation, right? And like I told you guys in the very beginning, my intent was not to, get you ready for a job. My intent was to give you a good foundation. And I think you've had that, and I certainly encourage you to, one, keep on reading the book, right? Because, I'm just giving you my view. You want to get the author's view too. And two, keep on building your skills. Work on becoming a professional in the field, and I promise you that everything else will come easier after that. Anise says, it's crazy how you walk us through these incredible insights. Thank you so much. I appreciate you saying that, just trying to build the next generation. All right, guys, so I've covered everything I want to cover today. So take care of yourselves, take care of your families. All right, take care of yourselves, and I'll see you next time, guys.